Hello, and welcome to this session on state design pattern. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The state design pattern is a behavioral design pattern that allows an object to alter its behavior when its internal state changes. It enables an object to appear as if it is changing its class, as the object's behavior is determined by its current state. The state pattern promotes encapsulation and separation of concern by representing different states as separate classes, each implementing a common interface. The main idea behind the state pattern is to encapsulate the behavior associated with each state into separate classes known as state classes. These state classes defines the method and actions that are specific to that particular state. The context class, which represents the object whose behavior is being controlled by the state, contains a reference to the current state object. The state design pattern is useful in scenarios where an object's behavior varies based on its internal state, and when you want to achieve cleaner code organization, improved maintainability, and extensibility. Hello and welcome back. Let's take another real-world code example implementing a light traffic system using the state design pattern. Again, I'm going to put the comment of state and context so you know which classes go for that. And in this example, we're going to implement a traffic light class that represents a traffic light system. The traffic light class maintains a reference to the current state, which initially is set to the red state. The traffic light method implements two methods which displays light and then change light. The display light method will return the current light state that we are on, and then the change light changes to the next state. Now let's implement the light state. And in the light state, we're going to bring in an abstract base class of traffic light state, and the abstract class also implements a display light and change light for every state that it implements. Now we're going to start by implementing the red light. The red light is the initial light state we have. So we're going to implement the red light. And then in the red light, we're going to also implement its display light, because the red light is a concrete class of the traffic light state. For display light, it returns red light. And then we also implement its change light method, and the change light method change to the next state. And the next state we have here is green. And then this is repeated again for the green light. I'm going to put all the codes for the green light here. For the green light, you see it implements the display light, which returns the light, and then the change light will change light to the next state. And the next state is the yellow light. And this is also the same thing in the code. You can see the yellow light displays yellow light. And then when you run the change light for the yellow light, it returns back to the red light. This is basically how the traffic light works. Now for the display light in the context, in the traffic light class, this runs for each state. Now, if the state is red light, it runs the display light for the red light, and if it is another state it finds itself, it's going to run that state display light. And then of course for change light, it runs the state change light method. After instantiating traffic light, every time you call the display light, it displays the current state that it finds itself. It runs the state display light method, and then if you want to change to another light, you have to run the change light method. Let's take an example, and let's start by instantiating the traffic light. And for the first traffic light, I'm going to print out the light that it returns. For the traffic light, run its display light. If we run this code, it returns the red light. And if you again, print out another display light. It's going to run red because that's the current state. If you want to change the state to the next stage, then you'll have to use the change light method of the current state. And the change light method of the current state moves you to the next stage. And as you can see here, the first one is red light and the second one says, let me put a print here. I like always separating the outputs. So you can see the red light was the first initial state, and then it changed state, changing from red to green. If I change the state again and then display it, you would see it's going to change to yellow. If this change state is not there, it's going to remain as green. But with the change state, it changes to yellow. Let me put this here again. So you can see every stage changes as I run this change state and the display light. Now again, it has changed to red. So you can see it changing from red to green to yellow and back to red, just like a normal traffic light will work, because every time we run the display light, it returns the current state. It returns the current state light. And every time we run the change light, it changes the current state to the next state. For red, in this instance, it changes it to the green state. And then if you run the display lights for the green state, it gives you green. This is just another simple implementation of the state design pattern. This video is part of a 20 hours Udemy course where we cover hundreds of real-world design pattern scenarios. The course is called Design Pattern in Python with Real-World Code Examples. We showed via practical coding how design pattern is implemented in real-world scenarios like event manager, cache, database connection codes, document management code, creating optimized configuration settings, login frameworks, GUI framework codes, plugin systems, game development codes, payment gateway, document generators, computer graphics generation codes, financial model code pattern, resource pooling, object pooling in ORMs, website creation, database query codes, language translator, web application framework creation, banking system codes, organizational chart creation, file system, interpreter, menu system, text formatting code, authentication code, authorization code, API for OS, document management system, create proxies, event handling, middleware in web development, workflow system, undo redo functionality in apps, job scheduler scenarios, parsers, chart applications, drawing applications, notification system, distributed system, booking system, workflow management system, sorting algorithm, file compression utility, and many more. If you are really serious about your career in programming, you have to get this video. And you don't have to be a Python programmer to use it. Use the link in the description to get the best price for this course on the Udemy platform.